So I'll demonstrate about the bridge teamwork performance showing the following tasks. The first one, perform bridge operating procedures addressing Ecdis. Second, activate bridge functions incorporating Ecdis. Lastly, navigate with Ecdis effectively. Now let's start with number 1. First bullet. Ecdis should be capable of displaying all SENC information. The System Electronic Navigational Chart means a database resulting from the transformation of the ENC by Ecdis for appropriate use. Updates to the ENC by appropriate means and other data added by the mariner. It is this database that is actually accessed by Ecdis for the display generation and other navigational functions and is the equivalent to an up-to-date paper chart. So number 1, SENC information available for display during route planning and route monitoring should be subdivided into 3 categories: display base, standard display, and all other information. Second, Ecdis should present the standard display at any time by single operator action. Third, when a chart is first displayed on Ecdis, it should provide the standard display at the largest scale available in the SENC for the displayed area. Fourth, it should be easy to add or remove information from the Ecdis display. It should not be possible to remove information contained in the display base. 5. The ENC and all updates to it should be displayed without any degradation of their information content. 6. It should be possible for the mariner to select a safety contour from the depth contours provided by the SENC. Ecdis should give the safety contour more emphasis than other contours on the display. 7. It should be possible for the mariner to select a safety depth. Ecdis should emphasize soundings equal to 2 or less than the safety depth whenever spot soundings are selected for display. 8. Ecdis should provide a means for ensuring that the ENC and all updates to it have been correctly loaded into the SENC. 9. Ecdis should provide a method to ensure that the ENC and all updates to it have been correctly loaded into the SENC. 10. The ENC data and updates to it should be clearly distinguishable from other displayed information. And lastly, Ecdis should be interfaced with a ship's first bullet, a ship's positions fixing system. Second bullet, to gyro compass, and third bullet, to speed and distance measuring device. Let's proceed to the second task. For any ships without a gyro compass, Ecdis should be connected to a marine transmitting heading device. Additional navigational systems incorporated into Ecdis can include but are not limited to AIS, radar, BDR, echo sounder, Navtex. The first one is Ecdis should be possible for the mariner to select a safety contour from the depth contours provided by the SENC. Ecdis should emphasize the safety contour over other contours on the display. Second, Ecdis should be possible for the mariner to select a safety depth. Ecdis should emphasize soundings equal to or less than the safety depth whenever spot soundings are selected for display. And third, display mode and generation of neighboring area. First bullet, it should be always be possible to display the SENC in a north-south orientation. Other orientation are permitted. Second bullet, Ecdis should provide for true motion mode. Other modes are permitted. And third bullet, when true motion mode is in use, reset and generation of the neighboring area should take place automatically at a distance from the border of the display determined by the mariner. So, colors and symbols. First bullet, IHO. Recommended colors and symbols should be used to represent SENC information. Second bullet, the colors and symbols other than those mentioned above should be those used to describe the navigational elements. Third bullet, SENC information when displayed at the scale specified in the ENC should use the specified size of the symbols, figures, and letters. And fourth bullet, Ecdis should allow the mariner to select whether own ship is displayed in true scale or as a symbol. So, displayed requirements and symbols, Ecdis must be capable of showing. So, first bullet, route planning and supplementary navigational tasks. Second bullet, route monitoring. Third bullet, the effective size of the chart presentation for route monitoring should be at least 270 mm by 270 mm. So, provision and updating chart information. The chart information to be used in Ecdis should be the latest edition of that originated by a government authorized hydrographic office and conform to IHO standards. Second bullet, the contents of the SENC should be adequate and up to date for the intended voyage to comply with Regulation V20 of the SOLAS 1974. Third bullet, it should not be possible to alter the contents of the ENC. Update should be stored separately from the ENC. So, display for other navigational information, radar navigation. So, in radar information or other navigational information may be added to the Ecdis display. However, it should not degrade the SENC information and it should be clearly distinguishable from the SENC information. Also, Ecdis and added navigational information should use a common reference system. If this is not the case, an indication should be provided. So, route planning, monitoring, and voyage recording. It should be possible to carry out route planning and route monitoring in a simple and reliable manner, including both straight and curved segments. Also, it should be possible to adjust a planned route by, for example, adding waypoints to a route, deleting waypoints from a route, changing the position of a waypoint, changing the order of the waypoints in the route. And lastly, it should be possible to plan an alternate route in addition to the selected route. The selected route should be clearly distinguishable from the other. So, connections with other equipment, Ecdis should not degrade the performance of any equipment providing sensors inputs, nor should the connection of optional equipment degrade the performance of Ecdis below this standard. Second bullet, Ecdis should be connected to system providing continuous position fixing, heading, and the speed information. So, performance tests, malfunction alarms, and indications. Ecdis should be provided with means for either automatically or manually carrying out on-board tests of major functions. In case of a failure, the test should be displayed. Display information to indicate which module is at fault. So, power supply, it should be possible to operate Ecdis and all equipment necessary for its normal functioning when supplied by an emergency source of electrical power in accordance with the appropriate requirements of SOLAS Chapter 2.1. Changing from one source of power supply to another or any interruption of the supply for a period of up to 45 seconds should not require the equipment to be manually reinitialized. So, proceed to the last task. The bridge mate electronic chart display and information system, or Ecdis, from Marine Technologies is an integrated information system that displays a vast area of navigation information utilizing electronic charts. So, designed with the vessel operator in mind, the bridge mate Ecdis is a vital resource for efficient route planning and monitoring. Incorporating user-friendly route planning functions, the BridgeMate Ecdis provides precise vessel position data, optimizing navigation, safety, and fuel consumption. Designed for the rugged offshore environment, the compact BridgeMate Ecdis system promotes intuitive operation with state-of-the-art touchscreen marine monitors. So the Ecdis is easy to install and service with a modular design that can be delivered as a standalone version or as a part of the empty BridgeMate. The BridgeMate Ecdis complies with regulations and is Wheel Mark approved, making it suitable for both new build and the retrofit installations. Also, the BridgeMate Ecdis uses official vector charts and accepts all in electronic navigational charts or ENCS distributed by Navtor and other distributors, including those from AVCS, Primar, and other chart suppliers. The BridgeMate Ecdis is optimized for fast and easy installation of Navtor charts. So, BridgeMate Ecdis features real-time positioning and route monitoring. Second bullet, advanced route planning and validation functions. Third bullet, simple low-cost update and maintenance of charts via email, DVD, or Navtor's NavSync online update service. Fourth bullet, interfaces to a large variety of a navigation sensors. Fifth bullet, compact and modular design of hardware options enabling ease and flexibility of installation on new build vessels and retrofits. Sixth bullet, maintenance-free marine computer. Seven bullet, touchscreen display available in 19, 23.1, 26 or custom size. And 8 bullet, compatible with S57 edition 3 electronic navigational charts encrypted using the X63 data protection scheme from Primar. Ninth bullet, displays targets and information for AIS. 10th bullet, intuitive menu structure for easy operation with built-in user manual. So, BridgeMate Ecdis options available charts, formats S20, S57, X63, and after SENC and distributions format. Second bullet includes free background charts. Third bullet, chart presentation S52 and INT1. Fourth bullet, fast import of electronic navigational charts including AVCS and Primar charts. Fifth bullet, easy chart updates. One-click chart updates with Navtor Navstick USB device. Seamless and automatic chart updates with Navtor Navvax. Sixth bullet, layers AIS radar targets, mariner objects, admiralty information overlay, and Navtex. Seventh bullet, user-friendly navigational tools. Eighth bullet, modern and intuitive user interface. Ninth bullet, Navtor chart distribution options. Pay as you sail. Licensed by route and standard subscription. 10th bullet, easy chart ordering with Navtracker with web portal. 11th bullet, optimized for touchscreen monitors. 12th bullet, track control steering. 13th bullet, autopilot steering. 14th and lastly, meets all international certifications and standard. So integration with the BridgeMate track control system. So the BridgeMate Ecdis can can be integrated with other MT systems, including the BridgeMate Track Control System, or TCS. In conjunction with inputs of position, heading, and speed, the TCS can automatically keep a vessel on a pre-planned track over ground under various conditions and within the limits related to the vessel's maneuverability. MT's track control system calculates and monitors any cross-track distance, or XTD, continuously in real time along the route, both on straight legs and during turns, and adjusts the course to steer, or CTS, or the rate of turn, ROT, as required to keep the vessel on track. The TCS is designed for safe navigation at sea and includes fallback arrangement at track control failures to meet all requirements. So this is achieved by monitoring sensor information usage of ENCs, CS, and in intuitive operator interfaces. So that's all. Thank you.